All right, welcome everyone. My name is Tristan Harris, and Ryan Moffett is on as well to help run the meeting. The topic today is setting up test sequences on a Bantam Plus, RW, and WE. We have a large group, so please remain muted. I will hold a Q&A at the end of the presentation, at which time I will read questions from chat and call on people who indicate they have a question. With that, let's get started. So, a quick overview. We're going to begin by navigating through Winboard Embedded software to find where the test sequence editor is. We are going to look at how to select your predefined test sequences, as well as editing those sequences. This will include exploring the different test parameters you can change, adding and deleting steps, applying received power, and saving those changes that you made. And then once we get through kind of all the introductory stuff, we'll also look at creating a custom test sequence from scratch. Now we will navigate to the software. So I do want to begin this by letting everyone know that I am using an emulator of the Winboard Embedded software, meaning I do not have a Bantam or a WE or an RW right in front of me. All this pretty much means is that there might be some bugs inside of this that you wouldn't encounter on your actual equipment itself. If any of those come up, I will make a note. With that being said, Winboard Embedded is a software that's used on the Bantam, the RW, and the WE. So although we're only looking at one piece of software, this does cover all three units. So first, we will go into Administration, and then Edit Test Sequence. From here, we will have a choice to do an ANSI test sequence or customer load test sequences. If you're generating a phantom load, then you would want to edit your ANSI test sequences. If you're using a customer load, then you would want to go in through the customer load test sequence. Now, both of these are set up in the same way. So if you can create a customer load test sequence, you can create an ANSI test sequence, as well as vice versa. So for today, we're only going to be looking into the ANSI test sequence. Upon entering it, you'll see that we are prompted with the test sequence editor window. We have our test sequences up here in the description dropdown. We have a toolbar right here on the right-hand side, as well as all of our test sequence parameters right here in the middle. First, we'll go up here to description. And when we click on this dropdown, we can see all of our already predefined test sequences. Right now in my database, I can see that we have 5 different test sequences. So this default one, for example, is a 3-step series test for full load, light load, power factor. If I go into something, let's say like this form 9, then I see that we have a larger test sequence with 9 steps. That does series tests as well as A element, B element, and C element. Keep things basic at first. We're only going to focus on this default. So now looking into the different testing parameters we have, the first column tells us what step number we're on. The second one defines what element we're testing. Our options are S for series, A, B, and C elements. S for series means that it's going to test all 3 elements together. So if I wanted to change it from a series to, let's say, a B element test, I could click on B, and it's going to change this element to a B. I want to change it back to series, click on it, select S. Next column is what kind of test we're running. Our options for our tests are full load, light load, power factor, creep, adjust optics, and demand. A creep step will simply just apply voltage to the meter. This can be nice if you want some kind of pause or kind of a stopping step within your test sequence if you need to change anything. You can go ahead and put a creep step in there, and once it hits there, it's going to wait until you manually move the test on. Adjust optics will apply voltage and current to the meter. And then demand will allow you to test demand registers inside of your meter if your meter has those. So once again, just like element, if I wanted to change this from a light load to, let's say, demand, I can click on demand, and it changes here. I want to change it back to full load, click the drop down, click on FL, I have my full load test back. Next column is the voltage percentage. This 100 symbolizes that it will test 100% of the test volts that you enter into the meter testing window. When you go into the meter testing window, you will define what voltage you're testing at. So if you say 240 volts is what you're running on your meter, then this will test 100% of that 240 volts. If I change this, let's say to 50, then now on step 1, it'll do full load test at 50% of that 240 volts, meaning that it will be running 120 volts on that meter during this step. I want to change it back to 100, press enter, and we're back to 100. The current column acts the exact same as the voltage, where it tests a percentage of the test current that you are running. So inside the meter testing window, you'll define what test amperage you want to use, and this will simply test a percentage of that. The next column, we have phase angle. This allows you to define a phase angle to test at. So if you wanted to do, let's say, received power, this is where you could define the current waveform to be at 180 degrees, and then you would get your reverse or your received power. By leaving it at 0, you're getting your power delivered, or your forward power. Moving on, we have our test/revs. By revs, it's speaking of the revolutions of the disk inside of the meter itself, whether if it's mechanical or solid state. By this having a...
Can I ask a question, please?
We'll be holding a Q&A at the very end.
Okay, thanks.
And at that time, I'll go ahead and open it up for questions, and we'll get you some answers. All right, so this column is for test time or test revolutions. So by having this set to 10, it's going to go ahead and measure 10 revolutions of that disk inside of the meter. So unlike these other ones, you can see the top is more of a dark gray rather than a beige. By clicking on this, I can change all of these values at one time. So right now, like on the other ones, I can change, let's say this one to 5, say okay. Now this is 10, 5, and 10. But if I wanted to change all of them, let's say to 1, I can click on this time/revs header. And then I can change it to 1 rev and say okay. And now all of them change to 1. So this is kind of a nice feature to where if you just need to change everything at once, you can click on it and do it. Moving on, we have service. This allows you to define what kind of service you're testing. So you can see you can test a single-phase service as well as a 3-phase service in both the Y configuration and a 3-wire delta and a 4-wire delta. So just like on times and revs, this is more the gray color, so I can click on service, change it to 3-phase 3-wire delta, and all of them will change because I changed it by clicking on the header. Moving on, we have standard mode. This defines what metric we're testing. So right now, they're all set for watt hour, but by clicking on this drop down, we can see that we also have var hours, we have Q hours, we have VA hours, amp hours, volt squared hours. We have a nice little array of options you can choose from for testing metrics. Scrolling over to the right, you can see we have optics. This defines what optics you're testing on with your equipment, meaning if you're using the optics 1, 2, or 3 panel, or if you're using any of our KYZ setups. Next column is for reverse or received power. So your options for this are Y and N, Y standing for yes, N standing for no. With it set to N, it will measure your forward or your delivered power. If you have this set to N, then it's going to go ahead and add 180 degrees to your phase angle, and it's going to be measuring your received power rather than delivered. Next column is frequency you're testing at. These next two are your upper and lower limits for your testing accuracies. So anything that tests above the upper limit column will test as a failed point, meaning anything right now that's above 100.50 will be a failed point, a failed accuracy. And the same thing goes for lower limit. If anything tests below 99.50% accuracy, it will be a failed point or a failed accuracy. And lastly, we have desired accuracy. This is the accuracy that you're ultimately shooting for. And that pretty much covers it for all of our testing parameters that you can go ahead and customize and change. Moving on, we're going to look at this right-hand side toolbar. We have at the top the save function. By clicking this, it will save any changes that we've made here to the test sequence in the description dropdown. So if I click save right now, it's going to save all these changes to default. Save as will allow us to save whatever test sequence we have up and open right now as a new test sequence. And if I click save as, I'll be able to save this as something different than default, and it will keep default unchanged. By clicking add, we are able to add a step or add a new test sequence. We'll look a little more into this here in a little bit. We have delete, which allows us to delete a step within our test sequence or to delete the entire test sequence, which we will once again go over this a little more in detail once we get done explaining the toolbar. We also have the print function. By clicking on print, we are able to either print this test sequence layout to an external printer or print it to a virtual PDF. If you ever need to print off your test sequence and put it onto like a USB drive, a junk drive, thumb drive, you can do a Microsoft print to PDF and click print. And this will then open up a window to allow you to navigate to your USB and save it under the file name of your choosing. Close. We'll close out of this window and go back to the previous one. And then we have our import and export features. If, let's say you have, this is on a Bantam Plus, and you want to take this test sequence and you want to put it over onto your coworker's WE-20. By doing export, I'm going to say no because I don't want to save these changes. But I can export my current test sequence out to like a USB drive and then save it as either a .txt file, .xml, .csv, .xls, or .htm, and then put it on their unit, and they can then use this test sequence that I've created. Once we've exported that file out onto the USB, we can take that USB over to their WE-20, plug it in, and then use import to then find that test sequence file that we exported and import it into their unit. This makes it really simple if you have a bunch of test sequences that you really like and that have proven to be very beneficial, and you want to replicate them on another piece of equipment. Instead of having to recreate them all on that piece of equipment, you can export them from one unit and put them onto the other. So now that we kind of understand all of our options, we can go ahead and begin editing this test sequence a little bit more. So let's say we enjoy this full load, light load, power factor series test, but we need to do all of this as well as measure received power. So we can leave these three the same. Then we can go over to add a new test step. Click add, and now we'll have the option of where we want to add the step. If I want to add it right after 3 as step 4, I can leave it as 4, or if I need to put it somewhere in between at the top, I can do that. So let's say, for example, I want to add a new first test step. I can say 1, and then add step. What this will do is it'll put in a new test step 1 right here and push all these down a step, meaning my now test step 1 will be 2, 2 will become 3, and 3 will become 4. We click add step. Now we see all this shifted down, and we have a brand new one right here. If I don't need this test step, then I can do delete, and then I can select a step to delete. So in this step, in this example, I need step 1 to be deleted. Select 1, over here to delete step, and now 1 disappears. Now to add in our reverse or our received power steps, go ahead and do add a step 4, add step. And now we can see it populates down here, but it has some information already pre-populated into it. The reason why step 4 does is because when you add a step, it'll copy the information above it and put it into the one that you're adding. Meaning when we put in a test step for 1, it had nothing to try and replicate above it. When we put in 4, it was able to replicate the information in step 3. So for this, now we just need to change our power factor to a full load test. And then we also need to have it be a received power step. So we have two options. We can either change the phase angle by 180 degrees, or we can scroll over to the right and change reverse to Y. So for this, I'm going to show both. So in this step, I'll change my phase angle to 180 and say OK. And now this is measuring reverse power or received power for full load on my test element. So now we'll add in our next step, add a new 5th step, click add step, and then we can change this to light load. You'll see that when I change this, my test current percentage will drop to 10, and my phase angle will go to 0. The reason for this is for some of our predefined tests, we've put in values for them, just to try to make it a little bit faster, a little bit simpler for you, so then you can go ahead and get through this quick and painless. So when I change this to light load, see current will go to 10, phase angle will go to 0. And then if you wanted to change these, if I actually didn't want 10%, I can change that to 15%, or I can change it to 100%. We put in those predefined values to make it a little bit easier, but you're more than welcome to change them as need be. So now for this one, to make sure we're measuring received power, instead of changing my phase angle to 180, I'm going to change the reverse column to Y. Now this 5th step for light load is measuring our power received rather than power delivered. Now we'll do add and add in a 6th step. This will be our power factor. And once again, predefined values, we'll see this 10 change to 100 and this 0 turn to 60. Now, because this copied the information from step 5, we'll see also over here our reverse is already set to Y. And now we have a 6-step test sequence that measures it measures delivered and received power. Now we can either save it and it'll save over this default, or we can do a save as and do, let's say, deliver received. Say OK. Now we see our test sequence name has changed from default to deliver/received. If we go ahead then and click on this dropdown, we can see we have it selectable here, as well as our default here. If we go back to default, okay, here's one of the kind of the wall bugs I was talking about with our emulator, is it didn't change right away. If I go back to deliver/received, there, I go back to default, and it changes back to our 3 steps. If you're using a Bantam, if you're using a WE, if you're using an RW, you won't encounter this issue. This is just because I'm using the emulator. So once again, we can see default has our 3 steps. We go to deliver/received, we have our 6 steps. So now, if I no longer needed this test sequence, it wasn't as effective as I expected it to be, or I just needed it for a specific application, I can now come over to delete and select delete sequence. This will completely get rid of this sequence. So once I say delete sequence, it will make sure that I want to delete this exact one. And if I say yes, it will then be erased from the database, and I will not be able to retrieve it unless if I recreate it. So I will say yes. Now when I go back to my dropdown, we see we no longer have that delivered/received. All right, so now that we understand how to add steps, delete steps, and what all we can change and use, let's go ahead and create a brand new test sequence from scratch for, let's say, a 3-phase meter. So I can go over to add and say add new TC, add new sequence. This will then prompt me to put in a description or a title for it. So let's do a 3-phase test and say OK. Now we have a completely blank sequence for us to test from. For us to set up that we can then test from later in our meter test sequence. Then from here, let's say for our 3-phase test, we don't need to do a series test. We just need to test A element, B element, and C element. So we'll say for our element, let's do A. For our test, let's say we need to do a full load, light load, power factor. We'll do full load on A, these auto-populate, and we need to change our service to a 3-phase configuration. So I'm going to do 3-phase Y. If I scroll over, and if I'm measuring watt hours and all this refills the requirements for the test, then I'm good to move on to the next step. Go over here to add. Say add in a step 2, add step. Now since we're still measuring A element, I can change my test to a light load. And keep my service the same, everything else, and then I'm done with this step. Now I can add in a 3rd step for power factor. From here, once again, everything else is already set up. It's already been defined by the previous test step. Now I can do the same for B element, do add 4th step, change my testing element to B, change it to full load. Once again, it's all good to go. 5th step for light load. The 6th step for power factor. Now I have my full load, light load, power factor for A and for B. So for my 7th step, then move on to C element. Change that to full load. And an 8th step for my C element light load test. and then add one more step for my power factor on C. So now from here, I have a 9-step test sequence created to test a 3-phase meter for specifically A element, B element, and C element. I can save it. Now all these changes have been made to the 3-phase test sequence. All right, from here, we're going to begin taking questions. To avoid talking over one another, please use the chat feature to pose your question or ask to be called on. I will read questions submitted in chat or call on you to ask a question out loud. All right, got a question from Kyle. When you export test sequences, do you export them all at once or one by one? Inside of Winboard Embedded, you'll export the test sequences one by one. Our next question. Sometimes the setting for optics is difficult. What's the best procedure for this? Can you go ahead and can you explain what optics you're trying to set up or which optics in general are giving you any difficulty, please? The alignment is not good. Hey, Moffett, do you mind taking this one?
So I'm assuming you mean like lining up the optic itself on like an electromechanical meter. If you would like to, Marcus chimed in on that one. If you want to talk to us directly after this, that seems like kind of a separate topic for this exact meeting, so we can discuss with you after this.
All right, our next question. Can you comment on the compatibility of imported/exported test sequences across equipment that does not run on Winboard Embedded, i.e. a full-blown test board? Moffett, do you mind taking this one?
I don't believe the sequences for Winboard Embedded are compatible with our WATNet suite, as they're formatted differently between the two units, one being for the test boards and what you run through BASIC versus ones that you create on the RW. They're formatted slightly different. So you may not be able to transfer those over between the two. No problem, Brandon. I appreciate it.
All right, next question. Is there a way to export the test settings from my 2350 board and to import to the WinBoard embedded environment? Correct me if I'm wrong, Moffett, but I believe that's exactly what you were just describing. Because they use a little bit of a different environment, we're not able to take test sequences from kind of WinBoard WattNet Basic for the 2350 board and import them into WinBoard embedded.
That is correct.
So regarding the question about the optics, I just wanted to let you know that when I tried setting the infrared sensor of the console to get pulses, it proved a little difficult, and then we just use a BNC connector to get the the output. So does that matter if we get the pulses out from the BNC connector instead of using the optics?
You should be able to use any optic and any input, depending on what the topic is or what the type of pulse you're going into it. The only thing that really changes between one optic versus the other is what optic you select inside of the test sequence.
Okay. All right. Thanks.
Yep.
Next question. Can you go through how you go about setting up a new profile? Are you talking about a new profile specifically in WinBoard Embedded? Or are you speaking about like a new profile in terms of setting up a new test sequence?
Setting up a new test sequence.
Okay, absolutely. And if we go back into the software, we can see over here in the right-hand toolbar, we have an add option. By clicking on add, we have the options to either add a new step to the pre-existing test sequence, or we can do add new sequence. By clicking add new sequence, we're prompted for a name for that sequence. So we can name it a new sequence and say OK. And then we are given a brand new test sequence that we can then go ahead and change to our liking. Does that answer your question?
No, not really. It's more on the profiles for, we have profile set 1, profile set 2, profile set 3.
Okay, I see what you're saying. So if you would like to go ahead and provide me with your email, we can go ahead and go through this either right after this WebEx, or I can send you that information later since that does differ from the topic we're discussing today.
Okay, thank you.
Would you like to go ahead and type out your email and send it to me, or would you like me to give you my email?
Yeah, if you can give me yours, that'd be great.
Okay, absolutely. So then at the end of the presentation, we have, you can either send it to this email, or I can give you my direct email address.
I can send it to that one. Thank you.
Okay, not a problem. All right, next question. What happens if you change the phase angle to 180 degrees for reverse and select yes for reverse? So if you go ahead and you change the phase angle to 180 degrees, you'll be getting received power. And then if you go ahead and also select yes for reverse, it'll add another 180 degrees onto that pre-existing 180, and then you will be measuring forward or delivered power. So then if you want to be delivering received power, you can either change the phase angle to 180, or you can just select yes for reverse. You don't have to do both. Doing both will get you delivered power.
So Tristan, one nice thing about checking the reverse power flow flag is that when you do have it in reverse testing, we log that as reverse testing. If you only enter 180 degrees, you log the test condition, but that reverse power flow does not get checked automatically.
Okay. Next question, more of a product-based question here, but does the RW have functionality that the Bantam does not, which may cause issues when exporting tests from an RW unit to a Bantam? For example, I believe the RW can create various harmonic conditions that the Bantam is not able to reproduce. Will Winboard throw an error, or would the test import and the Bantam crash when attempting to perform the test? Moffat, would you mind taking this one?
So between the two units, you should be able to import and export the abilities of that between the two. The only, well, no, I take that back. No, you should be able to do any test sequence because the test sequence setup themselves are the same between RW, Bantams, and WEs. The harmonic generation aspect of it is set up inside of your meter testing window, and then the amp difference between the Bantam and the RW, Bantam's limit being 50 amps while the RW's limit being 30 amps, that's set up in the meter testing window separate from the test sequence setup itself. So anything functionality-wise that differs between the two units should be able to still allow you to transfer the test sequences. But when you go to, let's say, generate harmonic content or generate above 30 amps or something, that's going to be product specific when you go into meter testing to set up that sequence specific to that unit, if that makes sense.
To add on to that, Ryan, the harmonics won't be a concern between the Bantam and the RW. And as long as the test sequence is driving a percentage of test amperage, which is driven from the meter form tables, you'll be fine there. But one area you do have to be mindful of is the service, the service condition. The Bantam only supports a series parallel service, whereas the RW will support true three-phase services. So you do have to be mindful of what the service condition is for the test sequence.
And then going off of that as well, if you try to generate a three-phase service on the Bantam, it will throw an error out to you and say, this is an invalid service type for this unit or this meter. So you will get an error if you bring that over from the RW, let's say, to a Bantam. That will show up when you try to generate that. And then one question that I saw that may have been missed that I wanted to address was, when you set the last test sequence, you left the rev as 1. Is that recommended, or is there a preferred minimum number of revs suggested for testing? Usually we go by the more revs, the better in terms of accuracy, because when you're looking at a meter and its accuracy, if you use 1 rev, you're going from a start pulse and a stop pulse, which increases the room for error of that meter. But usually the revs is either a decision made by the utility or something else, we don't really have a recommendation on that, but that's something up for you to decide when you're going through testing.
Yeah, usually most utilities will follow the standardization that they've had over the years, but it is absolutely recommended to work with your meter manufacturer on the minimum amount of energy considered valid for a test. There are a variety of meters that will support 1 rev testing, but there are some that expect more than 1 rev based on the low pulse constant that they have.
All right, let's wait about 15 seconds for any additional questions. All right, thank you all for attending. If you think of any questions, feel free to email technical support at technicalsupport@radianresearch.com, or you can call us at 765-449-5576. You can also visit our website at radianresearch.com. We enjoy being your solutions partner and look forward to working with you. I hope you have a great day, and we hope to see you in the next presentation. Thank you.
Thank you. You too.